All right. Now, uh, all right. So it has a bunch of information here. Okay. So we know what Z is, we know what W is, but we don't know what U is. So we'll start off with U. U equals whatever Z is, take away whatever W is. Okay. So that is going to be 7 plus I. Take away W, which is 3 minus I. And then it's going to be 7 plus I. Take away 3 plus I, because 2 minuses make a plus. And then you're going to end up with 4 plus 2I per U. So now we know that U is 4 plus 2I. Next thing we're going to do is V. So V is Z divided by W. All right, I'll just do it here. V equals Z divided by W, which is going to be 7 plus I divided by 3 minus I. Sam, do you know how to do these ones?
Yeah.
Go on.
Put on the other fraction, 3 plus I.
And
3 plus I.
now multiply it out.
21
Yep.
plus 7i.
21 plus 7I, yeah.
Plus 3i.
Plus 3I.
Plus I squared.
And what is plus I squared?
That's 1.
Awesome. And on the bottom?
9.
Yeah.
Plus 3i.
3I, yeah.
Minus 3i.
Yeah.
Plus 1.
Minus I squared, which is plus 1. Yeah, you're correct. Alright, the top part then. 21 take away 1.
20.
7I plus 3I. And 9 plus 1. 10. Down here. Divide by 10. Fold them by 10.
2.
2. And the other one?
5.
10I divided by 10.
1.
1I. So V is 2 plus I. Did anybody get that far? Yeah, because that's what you've been doing all along, isn't it? There's nothing new there. Alright, I'm going to rub out the right hand side. And then I'm going to move all of this probably over here in a minute. Oh no, that wasn't good. There you go. Ah. Oh god, that's not good. Sorry, Cormac. Absolute nightmare here. There you go. Just want to get my grid back. There you go. Now, I'm going to have to start plotting these now in a second, am I? Nope, still not on that yet. Alright, U equals KV. So it says U, which is 4 plus 2I, equals K multiplied by V. Alright, how much bigger is U compared to V? Look at it. Twice as big, isn't it? So you get 4 plus 2I equals 2K plus KI. And if you match them up, you'll figure it out quite easy. 2I, oh sorry, wrong colour. 2I is the same as KI. This means K must be 2. Essentially, it's twice as long. Is that right? So K equals 2. Yeah.
You don't like normal algebra? No.
Here? Yeah, you just write 2I equals KI, and then 2 equals K. Or if you use 2K equals 4, you get the same answer. And you still get K equals 2, normal algebra. Okay, phi equals L times U is the next part. So phi is 2 plus I, which is over this side. Alright, and phi equals L times U. So phi is 2 plus I, and it's L times U. Oh yeah. L times U. Alright. What do I have to do to U to turn it into V? What do you have to do to U to turn it into V? You have to half it, don't you? So you know L is going to be a half, don't you? But look, let's prove it. 2 plus I equals 4L plus 2Li. You can match them up the way you did in the earlier chapters. You can say 4L equals 2. And what happens when you have 4L equals 2? 4L equals 2. What does that mean for L? 2 over 4, which is a half. Yeah, so L equals a half. Now, in the description of the questions, you'll see this L element Q business. Yeah, that means it can be a fraction. Q means fractions, regular numbers and fractions. Well, n means natural numbers, so no fractions allowed. Or no, only whole numbers allowed. Does that make sense? Finally, I'm going to start drawing stuff. Okay? Oh, I have to draw u and v on the diagram. So that's the next thing I have to do. Do that earlier. Okay. What's the answer for u and v again, lads? U is 4 plus 2i. So u is 4 plus 2i, which is here. And v. Now, if you do that in a diagram, it's quite easy to see that u is twice the length of v in the same direction. So u equals 2v, or v equals a half of u. Does that make sense? Alright. Next thing, on your diagram, plot 2i squared v and minus iv. Alright, that's going to be difficult enough. Alright, let's start off with the... yeah, 1 sec. Let's go. Now guys, the problem is with 2i, so I have to do 2i cubed multiplied by v, and we all know v is 2 plus I. Now we got to convert that I cubed first, so what are we going to do with I cubed? We did tons of them 2 days ago. It's I squared by I, and what's I squared? Minus 1i. So this is minus 1i. Go with that? And then multiply by 2 plus I. Oddly enough, these two questions are exactly there.
Same.
They are, aren't they?
There's another
Oh, sorry, the 2. Sorry, I forgot about the 2. Sorry, my fault. They're not exactly the same. One of them's twice the size of the other one. So 2 plus I. Now multiply it in. Now what happens when you multiply by I cubed? What type of rotation are we talking about there? Nope. We're talking about 270 rotation, and if we multiply it by 2, twice as long. Alright, so what's our answer going to be? Our answer is going to be, it's going to be minus 4i, minus 2i squared, and we all know minus 2i squared is actually plus 2. And if I draw this out, 2 across, 4 down. Now you can see the original line, if I get rid of u, actually, just going to get rid of u for a second. It makes things a bit weird. So this is the original length of v. Now this is the length. When we multiply it by I cubed, we rotate it 270 degrees as expected. And then by multiplying it by 2, we essentially double the length, don't we? Alright. Now, next thing. What happens when you multiply it by minus IV? Minus IV is minus I times V. Now usually when we multiply it by I, we send it clockwise, don't we? Sorry, we send it anti-clockwise.
You know that you have to put that people's side.
V. See the way it says V here? I'll highlight it. See that little part there? It means use V. So I'm using V. Next thing. Multiply this out and what do we get?
Minus 2i.
Yeah.
Plus
Minus I squared is plus 1, so it's 1 minus 2i, which is half the size of the other one, isn't it? Alright, quickly does this. I'm just going to write down a few numbers. I want you to tell me what happens to your original complex number when we do it. We did this yesterday, okay? We'll see if we can find out. What happens if we multiply a complex number by 3i? What happens? Ben? How much does it rotate by? No, just I. Not I cubed, I. The I rotates it 90 degrees. And what does the 3 do? 3 times longer. Okay? What would 4i squared do? 4i squared. What would I squared do? 180 rotation, which means you come out this side, and you're 4 times as long. Okay? And finally, Connor, what about a half I cubed? What rotation are you talking about there? And half the original length. Yeah, thanks. Alright. Now, here we go again, guys. We're doing this one here. Oh god, this is a difficult question. Yeah, these are quite difficult. Now, they do occur at the end of the exam. So, they occurred in they occur in the Part B section of the Leaving Cert paper, so they have been known to do this. So you just might as well just keep it reasonably that you know these reasonably well. All right. How do I verify it's a solution? First of all, does anybody remember?
You put 2 plus 4 in the section.
Or you can do the minus b formula, your choice. Okay. So to verify that it is a root, you put 2 plus 4i in, and you square it out. Okay. So remember, you're going to be practicing some of these later on, so you need to be sharp on them. So, is everybody happy with the first one? We're just putting it in, and we're making sure that it turns into 0, proving it's a root. Okay. 4 plus 8i plus another 8i plus 16i squared, which is minus 16 minus 8 minus 16i plus 20. You guys have a better way of doing this than I do sometimes. You guys put all the real numbers together, so you do it like this. You go 4 minus 16 minus 8 plus 20, and you say that all turns into 0. If you have different color pens, your examiner will like you for it. So see the way I'm sort of grouping the i's and the regular numbers together? It's good exam technique, so it's a good idea. Alright, and I proved it's a root then, didn't I? Because they both turn into zeros.
You have 3 dots.
Huh?
You have to do 3 dots.
3 what?
3 dots in triangle.
3 dots of a triangle?
1, 2, man.
I don't know. Alright, we're done there. And find the other solution. Well, the other solution we know is the conjugate, isn't it? If one complex number is one solution, the conjugate is the other. You would get that if you did the minus b formula, okay? Now, let's find out what's going on here. Plot Z1 and Z2 on the Argand diagram. Sam, where is 2 plus 4 right?
2 to the right plus 4.
Yeah, and that is Z1. Now, where's the conjugate located then?
2 minus 4.
2 minus 4. So is everybody happy that's Z1 and Z2? They're conjugates of each other, which means they're mirrored in the x-axis, yeah? They're mirror images. Now, what does it want from me now? Is IZ1 the same as Z2?
No.
Now let's look at it. Are they 90 degrees apart, do you think? I don't think that's 90 degrees. I think it's above 90 degrees. Do you? Not the distance, the angle. They're asking is IZ1 the same as Z2? IZ1 rotates at 90 degrees. So I expect IZ1 will be over here somewhere.
How do you know that's like absolute angle?
No, it's just asking are they the same. Is IZ1 the same as Z2? We'll do it using algebra. So put in I, and what's Z1?
4.
Equals Z2, and then you get 2i plus 4i squared, and then 4i squared is minus 4 plus 2i, and it's not the same as Z2, which is 2 minus 4i. They're not the same thing. Remember what I said earlier, when you multiply Z1 by I, you basically rotate it 90 degrees. So you rotate it all the way over here. So if that's Z1, this part over here is I Z1. I'm just going to pause it for a sec, just in case I lost it. Alright. So IZ1 and Z2 are not equal to each other. Describe the transformation that maps Z1 onto Z2. So there's Z1 and there's Z2. What transformation would send Z1 down to Z2? What do you reckon? Alright, we'll try I cubed. I don't think I cubed will, but we'll give it a go. Yeah, so it would send it 270. I don't think it's 270 though. We'll find out. I cubed Z1. So we'll do I cubed, which we all know from earlier is minus I, don't we? Yeah.
Does it always send it counterclockwise?
Anti-clockwise, yeah. And what we get there is 2 plus 4i. and then we get a minus 2i minus 4i squared. Minus 4 times minus 1 is 4 minus 2i. So it's actually over here. That's I cubed z1. So as you can see, it should be directly opposite iz1. So they're not the same thing. So there's no rotation that will do that for us. So we have to figure out something else. There's something that's called a translation. Do you know what translation is? I'll tell you now. A translation is when you have a point and you move it a certain distance. So imagine I have this point here. See this here? And imagine I want to move point 1 to point 2. How do I do that? 2 across and 1 up. Or in complex numbers terms, I'd add 2 plus I onto it. 2 plus I means 2 across, 1 up. So what we can say is, how do I send Z1 all the way down to Z2? Minus 8i. So you can say a translation of minus 8i added to Z1. Do you see what we did there? By adding on minus 8i, you send it 8 blocks down. Or the other answer might be it's just the conjugate. Okay? So that's the transformation that will do that. That's a difficult question. Investigate whether the image of Z2 under axial symmetry is in the imaginary axis has the same position as I squared Z1. Oh God. Alright, let's dissect the first part. Is there anything you don't understand here? Do you know what image means? Original point. The original point is the point, and if I rotate it 90 degrees, that one will be the image of it when I rotate it 90 degrees. So the image is not the original point. Do you get what I'm saying? It's what you do to the point. So everybody happy with the word image now? Does everybody know what axial symmetry means? There's a line, and you're going to send it through the line and the same distance out the other side. Does everybody know what imaginary axis means? The straight line, the vertical line, not the horizontal line. If that said real axis, what would that mean? The real is the horizontal, the imaginary is the vertical. Okay, so let's look for Z2 right now. Where is Z2 located? There it is there. Now do an axial image in the, do an axial symmetry in the vertical line. So where'd you end up? 2 across and another 2 across. So you end up here. It's just a straight line. You just go straight across. Axial symmetry in the real axis, okay? So, is everybody happy? Yeah, 1 sec. Yeah, alright. Alright guys, look at this. So, there's your image, yeah? Now, I have to figure out, is this image, or this location, is it the same as, what did he ask me? I squared Z 1. Where do you think I squared Z1's going to go? 180 degrees straight through the other. And they are the same, aren't they? You'd probably need to prove it though. So what's I squared? Minus 1 times Z. And then you multiply that out, and you get minus 2 minus 4i. In fact, they are the same thing, and we're done. You guys try questions 4 and 6 now. Off you go.